Okay, this is the first video on ratio and proportion, an introduction to ratio and proportion. Most of this stuff is in your notes. And it starts off with the ratio of A to B can be written as a couple of dots in B. That means a ratio of A to B, or A over B as a fraction, A over B. When two ratios are equal to each other, they are said to be in proportion. And so A over B, if A over B equals C over D, we say that the two ratios are in proportion. Okay, so let's take a little bit closer look at what that means. Well, if you have a small pot of tea that can take like 3 cups, and you put two spoons of sugar in it, it'll make it a certain kind of sweetness. Well, if you make 6 cups of tea, to make it the same sweetness, you're going to need 4 spoons of sugar. Well, the deal is that 2 spoons of sugar to 3 cups of tea is an equal ratio as 4 spoons of sugar to 6 cups of tea. The ratios are proportional. Okay, so that kind of gives you an idea what's going on. If you look at a rectangle, these two rectangles are proportional because the ratio of the width to the length is this one is 2 to 3, this one is 4 to 6. Those two ratios are called proportional. Okay, now if you are given that A over B equals C over D, it's important to realize that you can write it in another form. If you multiply both sides by the denominators BD, the B's will cancel here, and you'll get A times D. And the D will cancel here, and you'll get B times C. Take a close look at that and make sure you understand it. And it's also important to be able to put it in other forms, so that if it's A over B equals C over D, you should be able to see that if I flip both fractions, it'll be true as well. B over A will equal D over C. Also, if I took this A times D and B times C, and I divided both sides by DC, the D's would cancel, the C's would cancel, and I'd get A over C equals B over D, another way of expressing the same thing. And then if I inverted both of those fractions, I'd get yet another one. Now, what is the point of all this? Well, we're going to be getting ratios with triangle sides and things, and we want to be able to manipulate the equations so that we can put the thing we're looking for on top. So if we're looking for side A, this is a pretty good equation here if we know B, C, and D. Because if C is 3 and B is 6 and D is 9, we just substitute those values into this formula and then multiply by 3, and we get A over 3 equals 6 over 9. We multiply by 6 and we get 18. Divided by 9, we get A equals 2. There's one more thing that's really important. It's called the mean proportional. If you have A over B equals B over C, if I cross multiply here, if I multiply both sides actually by C, B, the B will cancel here. You'll get AC, and the C will cancel on the other side, and you'll get B times B. So you'll have B squared equals AC. Well, if we take the square root of B squared, we get B, and the square root of 36 is 6. So this B, the square root of 36, is also called the geometric mean of A and C. But this comes up in questions where if you've got A over B equals B over C, know that it can be written in this form. And I remember problems like this that we have to do, where we get 4 over B and B over 9, and we get clever and make it B squared equals 36 and get the answer here. So this is kind of important. Hope this helps.